Hi, welcome to this lesson on number patterns, finite geometric series. Let's have a look at question 4 on solving finite geometric series problems. We're told that the third term of a geometric series is 50, and the fifth term is 1250. The product of the second and third terms is negative 500. So product, second and third terms is negative 500. Find the sum of the first 8 terms. Okay, so this geometric series looks like this. It's A plus, so it's term 1, plus term 2, plus term 3, plus term 4. Right, plus all the way up to, we want up to the 8th term. So AR to the 7, always one less than the exponent, right? But we know the third term in this geometric series here, T3, is 50. We know the fifth term, so let's just write out one more there, AR to the 4. And we know that this term here is 1250. The product of the second and third terms, so basically T2 times T3, right, that is negative 500. Find the sum of the first 8 terms. Okay, so I'm just going to label that equation 1, the product of the second and third terms, negative 500, because we must make sure we are using all the information that we're given. Okay, so first of all, we know that AR squared is equal to 50. All right, from T3 here. And from T5 here, we know that AR to the 4 is 1250. So these types of problems are quite common, and the trick to them, because everything is dealing with ratios and multiplication when it comes to geometric, the division is very helpful as a technique here. So what we're going to do is, let's take, so this is T3 and T5. Let's take T5 divided by T3. I always do higher power divided by lower power. The reasoning is that we're left with usually one variable left over. In this case, AR to the 4 divided by AR squared. That's the left-hand side. But what about the right-hand side? That's 1250 divided by 50. Okay, that's the right-hand side's terms. So therefore, these A's will divide and the R squared will divide in here to just leave you with R squared. R to the 4 divided by R squared is just R squared. That's using exponential laws again, because you have R to the 4 minus 2, which is R squared. And let's see what 1250 divided by 50 is. 25. Nice. Okay, so how do we solve here? Remember, you're solving for a variable expression squared equals a constant number. Therefore, when you take the square roots on both sides, you must be careful to remember that it is plus or minus 5. How do we know which is the correct R though? Well, we haven't used this piece of information yet, so that tells me that that's probably going to come in handy. So first of all, let's see what happens when R is positive 5, right? It can only really be one of them, but maybe it might be both. That's why we got to check. So when R equals 5, if I use T3 now, AR squared equals 50, well, we know that R was positive 5, that's what we worked out, squared equals 50. So 5 squared is 25, and I divide both sides by 25, and 50 divided by 25 is 2. So I get A equals 2 here. So what does the sequence look like? It's 2 for the first term. Then the common ratio is 5, so you just keep multiplying by 5. So 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. And so on. Okay? But we know that the second term times the third term was given as negative 500. That was given information. So here's my T2 and T3. 10 and 50. But when I multiply those two guys, I get 500. Positive 500. But they told us the product of the second and third term is negative 500. So therefore, R equals 5 is not a valid solution. So this must mean then that R equals negative 5 must be the solution here. So let's go ahead and clean up sum of that over here. Okay. Okay, so now let's check when r equals -5. So here, again, I'm going to use T3, AR squared equals 50. But r is -5, and you're squaring it, equals 50. -5 squared is positive 25. And if you divide both sides by 25, you get a equals 2 again. So the same starting off term. Start with 2. But now you're multiplying by -5 each time. So it becomes -10. -10 times -5 is positive 50. Positive 50 times -5 is -250. So you can see how each term alternates between positive and negative here because of that negative ratio. And T2 times T3 here, -10 times 50, that does give me -500, just like the information said it should. So therefore, when r equals -5 and a equals 2, that will be the correct general term. So therefore, I get Tn equals a, which is 2, times r, which is -5, to the n minus 1, where n is a natural number. So we've worked that out now. We've got the general term formula. So let's go ahead and clean that up. Okay. So now that we have the general term sequence, we know the a value and the r value essentially. They asked us to find the sum of the first 8 terms. So S8. But because my r value, r equals -5, is less than 1, I'm going to use the second formula, which is a times 1 minus r -5 to the n, which is 8, over 1 minus r, which is -5. But I know my a value, so let me rather write a there. That is 2. So what do we have? 2 into 1 minus -5 to the 8. Notice how I didn't distribute that negative into that brackets there, because that brackets -5 is first being raised to the 8, then it's being subtracted, right? Where does that come from? Our good old friend, BODMAS, right? Brackets take the first operation and O of your exponent, then subtraction in the front is happening to it. 1 minus -5 is 1 plus 5, which is 6. So let's get ahead and pull up the calculator there and put that in. So it's 2 into 1 minus, open brackets, -5, close brackets to the power 8, all over 6. And I get -130,208. And that is the final solution here. All right. I'll see you in the next one.